everyone. Today we're going to do the single phase and three-phase transformer. Our hardware includes a transformer board that has three phases that could be used individually. On one side of the board you see the three windings for primary, U, V, and W. On the other side you can see the secondary for U, V, and W. The board includes three light bulbs that are acting as our load. For each side, primary or secondary, we have two windings that could be used either separately, or you could use a jumper to put them in series and use them as a single winding. Every pins is numbered, is marked and labeled by numbers and letters. For example, this pin is called YU1. The 1 means the primary, and the U1 and the V1 and the W1 means that the first winding or secondary windings on the primary side. So we're going to start doing the connection. The connections are given in the lab manual, so feel free to take a look before we start. Okay, so the connection is done. You have to look at your wiring diagram on the lab manual to find out what we have really done. So you don't have to follow the wiring from the video, you have to follow the wiring from the manual. So I'm going to set the function generator, the three-phase power supply. The table says set the frequency to 50 Hertz, so I'm going to set it to 50 Hertz. And the voltage is supposed to be set to 12 volt. So I'm going to turn it on and just pull it aside, and then there is a current meter, so I'm going to click on the current meter, and it's saying set it to 200 to 500 milliamp. So I'm going to set it to 500 milliamp, and it says RMS. It's already on RMS. The resistor that we are using by default is 1 ohm, so we have to set the resistor to 1 ohm. So this one would be 1 ohm, and again it went to 5 milliamp, so I'm going to bring it down to 500. So it's showing 151 milliamp. I won't be able to tell you what current is this, but you have to just follow the lab manual and tell me what this current which I am measuring is going to be, and enter it into your lab manual. And then the next one is another meter. This meter is supposed to be set to 20 volt, so I set it to 20 volt, and it's AC, so I'm going to set it to AC, and it's already RMS, and the number that I'm reading is 12.3. So again, you have to look at your wiring in the lab manual and tell me exactly what is this 12.3 volt is measuring. I'm going to turn off the power supply. Then I'm going to close this too, and I'm going to open the oscilloscope. So for the oscilloscope, it says set the channel A to 200 millivolt. So this is 200 millivolt, and channel B to 10 volt. So channel B to 10 volt. They're both supposed to be AC, so I'm going to set channel A, and channel B is already AC. The trigger is supposed to be channel A. I'm going to set the trigger to channel A, and the time base is 10 milliseconds. So 10 milliseconds. I'm going to turn this on again, and I'm going to just say single, so it stops. And then what I'm going to do, I can drag this and pull it here. So the oscilloscope is showing the voltages and currents. Again, you have to look at the connection to channel A and channel B, and let us know what is the red channel about, what is the blue channel about, and then that would be the experiment for no load test. There are a couple of multiple choices that you have to answer. Don't forget that for any multiple choice, if you are using a formula or if you're supposed to come up with some reasonings before you get the answer, we need those formulas and we need those reasonings to be added to your lab manual. So you do not just use check couple of questions and without any reasonings or without any formula. But if it is based on pure observation, for example, it says after you turn on the power supply, what did you see? And for example, you see the light bulb is on, you don't have to explain because this is pure observation. There is no formula, there is no reasoning. You just saw that the light went on, so you check the answer that says light went on. For those things, you don't have to bring any reasonings or formula for the multiple choice. This is very important. You're going to lose marks if you do not follow the requirement for the multiple choices. So I'm going to turn this off, and the first experiment is finished. Next experiment is the transformer ratio. In this experiment, we use the formula that V2 over V1, which is the voltage of secondary divided by voltage of primary, is equal to N2 over N1. What we do, we apply the voltage to two windings, and assuming that we know the number of turns for one of the windings, you can put it in the formula and find the number of turns for the other windings. So the first part, we apply the voltage to the winding between 1V2 and 1V1, and then we measure the voltage between 2V1 and 2V4. 2V2 and 2V3 are connected together through a jumper. So if you measure the voltage across 2V1 and 2V4, assuming that we know the number of turn between 1V1 and 1V2, which is 156, so that's known, the number of turn, 156. The voltage we are applying to the first primary winding is known because that's what we set up with the or we measure it through channel A. So channel B is going to show the voltage across there. We know the number of turn between 1V1 and 1V2. So if you sub it in the formula, the number of turn between 2V1 and 2V2 is going to be calculated. So the voltage is set up for 12 volt 50 Hertz, and the voltmeter A is showing 11.3, voltmeter B is showing 12.2. The number of turn is 156 based on the manual, so you can sub it and just find the formula for the other ones. In this part of experiment, we change the voltage applied to the primary and we measure the voltage applied to the secondary. Since the voltage across the primary is measured by voltmeter A, which is on the left side, the secondary voltage is the one measured by channel B, which is the meter on the right side. So I have to change the power supply and then read the voltage on the primary and match it with the first column of the table. So I can start from like bottom to top. So the 12 volt, this is already 12 volt, even though the primary is not 12 volt, but we consider it, it's not a big deal. Or alternatively, you can change the primary to look it at 12 volt. So I'm going to change it to make it 12 volts. So this is almost 12 volt on the left side, and the number on the secondary, the voltage is 12.9. So here you have to enter 12.9 for the 12 volt. Then I'm gonna lower it for 11. So for 11, the secondary is 11.8. Then I go to 10. secondary is 10.8. I go to 9. Secondary is 9.4. I'll go to 8. Secondary is 8.4. I'll go to 7. Secondary is 7.1. I'll go to 6. 6.2 almost. I'll go to 5. Secondary is 5.1. I'll go to 4. Secondary is 4.1. 3. Secondary is 3. 2. Secondary is 2. And finally 1 volt. Secondary is 1 volt. So you notice that I was only looking at the power supply voltage, not on the voltmeter A. There is a slight difference, but it's not huge to change the result. So you have to fill up the table, and then also you have to plot these numbers on a graph and let us know the behavior of the transformer. If the behavior is linear, if it is not linear for some parts, you have to explain why it is not linear for some parts and it is linear for the other part. And in general, you have to explain a variety of things here regarding the behavior of secondary and related to the primary. In this part, the lab manual is asking to measure the number of turn for N21, which is one of the windings on the secondary, and N22, which is another winding right beside it on the secondary. So you have to use the formula for the transformer that says V2 over V1 is N2 over N1. So we already know that N11 is 156. So this is given in the lab manual. So number of turn for N11 is given. If we need to measure the number of turn N21, you have to apply a voltage to the N11 winding and measure the voltage across N21. The same thing for N22, you have to apply a voltage at N11 across N11 and measure the voltage across N22 and use the formula to calculate N22 and N21. So N11 is already connected to 12 volt and 50 hertz. So we know that 12 volt is across N11. And what I did, I connected the N21 and N22 to channel A and channel B. So here you can see that I connected the channel A. This is channel A. I connected to N21, and this is channel B. I connected to N22. So these 2 meters are measuring the channel, the voltage across N21 is measured with the left multimeter, and the voltage across N22 is measured by the right multimeter. So you have to use the formula, and assuming that we know the N11 is 156 turn, measure the N21 and calculate N21 and N22. In next part, the lab manual is asking to measure the N12, so the second primary windings. In order to do that, the lab manual is suggesting to apply the voltage to 1V3 and 1V1. Before, the voltage was applied to 1V1 and 1V2. Now it's suggesting to apply to 1V1 and 1V3. That's what I did here. So now the voltage is connected to both sides of 1V1 and 1V3. And you can see that the voltage on the multimeters has changed for the secondary. It was 6.2, now it's 3.6. So there is a change. So the lab manual is asking you to find out the number of N12 based on this change. So again, you have to use the formula in in a smart way to find out the N12 considering that there is a change here from 6.2, it went down to 3.6. So in next experiment, we investigate the response under load. So what we do, we apply the voltage to the primary, and then we experiment the behavior of the secondary when it is connected to load, when it is not connected to the load. So for the first part, we do not connect the load. So our load is a light bulb. So what I did, with the this is the connection, so you have to follow the connection from the lab manual. I just made the light bulb loose, so it is not connected. If I tighten it properly, it's gonna turn on, but the reason you see it off is because I made it loose, so it's not connected. And in this case, we are measuring the current and voltage across the load. The current is measured through this resistor board. So basically the whole concept is that in order to measure the current, you connect the voltage across a 1 ohm resistor through channel B. So channel B is measuring the voltage across the current that goes through a 1 ohm resistor. And based on the Ohm law, we know that a current going across a 1 ohm resistor is equal to the voltage of that resistor. So if you measure the voltage, in fact, you are measuring the current. So these two the multimeters, the one on the left is measuring the voltage, the one on the right is measuring the current. We did all the settings for 500 milliamp
In this part,
range,
we are going to investigate
the
response
under the load.
So I have
the current
tightened
is
the
4
light bulb,
milliamp,
so
and
it
the
came
voltage
on
is
because the voltage is applied
12.4
through the secondary to
in
the
this
light
case.
bulbs. So you can see the voltage has changed and the current has changed. You can see the measurements on the multimeters. And in next step, we need to observe the voltages on the oscilloscope. So I'm gonna just click on the oscilloscope and set up the voltages for channel A and channel B, and on your lab manual you have to explain the voltages, that why like with the numbers, and answer the question based on what you see on the oscilloscope. In this part, we are investigating the response under the short circuit. So what I'm doing here, I'm shorting um, the secondary of the transformer. So the secondary of the transformer is shortened by means of this cable that is connected on the both circuit. You have to be very careful when you short circuit the transformer. You have to start with a very, very low voltage. So that's why I'm gonna start with 0 volt here. So I'm gonna set the voltage here. This is 2 volt and this is 500 millivolt. Is already there, 1 ohm. So settings are okay to measure the voltage and current. Then I'm gonna turn it on. You see that the current is only 5 milliamp because I'm starting from 0 volt. Now the lab manual is asking to increase the voltage until we get to 0.3 amp, which is 300 milliamp. So this is already 300 milliamp or 0.3 amp, and the short circuit voltage, I can see that the over the range light is on, so I'm going to increase the range a little bit so this light goes off. So I'm not using a wrong range. So 1.29 or 1.30 volt is the short circuit voltage. You need these values that you see on the multimeters to sub in the formula and answer the questions that are asked in the lab manual. This experiment is the auto transformer, which is the step down, and then we do a step up in the next experiment. So you remember we said that the hardware board has a primary with 2 windings, so windings of 1V3 and 1V1, and then windings of 1V1 and 1V2. So we could use these 2 windings to form an auto transformer, which is a step down. If we use the primary as like 1V1 and 1V3, if we apply the voltage as primary and take the 1V1 and 1V2 as the secondary, because the number of turns at the secondary is smaller than the number of turns at the primary, this would be like a step down transformer. So I'm gonna apply the voltage here. So this is the voltage at the primary, this is the voltage at the secondary. So you can see that the voltage at secondary is lower than the voltage at primary, and this is a step down transformer. Next experiment is the step up auto transformer. So we choose and we connect the same two windings from the primary, but we change the primary and secondary. So now the voltage is applied to 1V1 and 1V2. So this like a smaller like windings, and the secondary will be measured between 1V1 and 1V3, the bigger windings. So in this case, the number of turns at the secondary is higher than the number of turns at the primary. So then this would step up the voltage, and this is something that you can also observe here, that the 11.3, 11.4 is the voltage applied to the primary, and you can see that the voltage at the secondary is higher. So you need these voltages and measurements to answer the questions for the experiment of a step-up auto transformer. So that's the end for the lab 1, which was transformer, single phase, and the auto transformer. And I hope you guys were able to get all the measurements, and we are looking forward to get your lab reports based on the measurements and based on what lab manual has been asking from you guys to do it. Good luck, and thank you for watching the video.